In our first two examples, we're going to solve our inequalities graphically. So example 1 says to use the graph of the function to solve the inequality. And so we will have a part A and a part B. The first one I want to know when f of x is greater than 0. And so that's another name or another way to just simply say when y is greater than 0. And so where is y greater than 0? Well, here's all my y values. Y is greater than 0 above that x-axis. So we are talking about this portion here of my graph. Now, if you notice, I did my best to not include that x-intercept. That is not included since it's not or equals to 0. So we have two portions here. We have this portion right here, and then this portion right here. So this portion is all above that x-axis. So we're going from negative infinity to it's approaching this vertical asymptote, and we know vertical asymptotes from last lesson means it's going to approach it but never touch it or cross it. So to -1. So then the union of this portion here, it's crossing right here at 0, 0. So it's from 0 to, and then it's approaching this vertical asymptote, which is at 4. So 0 to 4. Okay, so now B wants to know when f of x is less than or equal to 0. And so that's another way of just simply saying when y is less than or equal to 0. So where is my y values here? Less than or equal to 0. Well, they're less than down here because this is where all my negative y values live. And they also equal 0 on this x-axis. We're talking about everything in this portion of my graph. So we have this part right here. We go from -1 to 0. Now we need to be careful when we're talking about rational functions when it comes to brackets and parentheses. When it's less than or greater than, everything here is going to get parentheses, very straightforward. But when it's less than or greater, or sorry, when it's less than or equal to or greater than or equal to, we have to pay special attention to what gets brackets and what gets parentheses, mainly what is a 0 and what's an asymptote. Because this -1 is talking about this vertical asymptote, meaning it's never going to touch it, never going to cross it, it does not include this number here. So this is a parenthesis. It's going to be a parenthesis no matter what because of that vertical asymptote. And then here at 0, because it equals 0, this 0 here is included. So we'll get a bracket. So then union, this portion here is going from 4, that vertical asymptote, all the way to infinity. Again, vertical asymptotes, it doesn't matter that it or equals to, it's never going to cross this line right here. So it gets a parenthesis, and infinity is always parenthesis. Okay, so these vertical asymptotes are kind of the new thing that we're introducing here. So even though this is less than or equal to, we only have one bracket in this set of solutions, and that is representing that 0. Okay, let's try another example. Solve the inequality when r of x is greater than or equal to 0, and then it gives me the function. So if I'm wanting to know where this is greater than 0, we're talking about y values here that are more than 0, that are positive, and that's everything above that x-axis. And since this is or equals to, it also includes this x-axis. Includes our x-axis. And then everything above. Okay, so we have two different parts here, it looks like. We have this part and this part right here. So this is from -infinity 2, it's approaching this asymptote here, which is at -2. So even though this is or equals to, this is going to get a parenthesis because of that asymptote. And then the union, it looks like it's crossing right here at -1 and then going to infinity. So infinity is always a parenthesis, but because this is or equals to 0, this 0 here is included. So again, one bracket, even though it's an or equals to, because this is a vertical asymptote. Now I could stop the video right here, but I want to kind of introduce you to what we're doing next video. We're going to have to start solving algebraically, and algebraically means I need to find these two things here. What did this -2 represent? That vertical asymptote. What did this -1 represent? This x-intercept, or this 0. So to do that, from last lesson, to find my 0, I'm going to take the top 5x plus 5 and set that equal to 0 and solve it. So we would subtract that 5 over and then divide by 5 to get x equals -1. So we have an x-intercept at -1, 0, which is what we have on that graph. So then to find our vertical asymptote, I would take now the denominator, 3x plus 6, and set that equal to 0. So subtract your 6 and divide by 3 to get a vertical asymptote at x equals -2. So these are the two things that we need to be able to find when I'm going to solve these algebraically.